Now we will continue our journey to finding the exponential form of more complex numbers. We said that when z is given as cosine theta plus I sine theta, its exponential form is e to I theta. When z is cosine theta minus I sine theta, its exponential form is e to minus I theta. These two numbers have norm 1 or modulus 1. When z is minus cosine theta minus I sine theta, its exponential form is e to theta plus pi. Okay, now let's have this number minus sine theta plus I cosine theta, and let's find its exponential form. That means we need to write z as the norm of z e to some angle alpha that we have to determine. So first, what's the norm of z? So we know that the norm of z is just the real part squared plus the imaginary part squared, and this gives sine squared plus cosine squared. This is sine squared of theta plus cosine squared of theta, and we know this is 1, square root of 1 is 1. Okay, now we're going to use Euler's formula for the sine and the cosine to determine an expression for the exponential form of z. So we know that sine theta is e to I theta minus e to minus I theta over 2i. Be careful, always don't miss these two i's. And cosine theta is e to I theta plus e to minus I theta over 2. So we plug them here and we see what happens. Okay, so z is minus sine theta plus I cosine theta. So it's minus. So the first thing is minus e I theta minus e to minus I theta over 2i plus e I theta. Don't forget the I. Okay, very important. Okay, plus e to minus I over 2. So the first thing here, we need to get rid of this I here in the bottom. So we know that I squared is minus 1. That means I times I is minus 1. That means I is minus 1 over I. That means 1 over I is minus I. Or you can use the conjugate. So 1 over I is minus I. So we have to multiply by that. So once we multiply by here, this 1 over I, so 1 over I is minus I. And once we multiply, we get an I. So we have 1 over 2. Okay? So I e theta minus I e to minus I theta plus I e I theta plus I e to minus I theta. Okay? And we see that we can cancel by which ones? These two. Okay? No, sorry, it's not this. No, this one and this, not this one. Sorry, this one and this one. So this one and this one, and we get 1/2 2i e I theta, and by the end we get I e I theta. We have to get rid of this I. Why? Because everything here in the front of the exponent must be positive number. Remember this expression. So this is the general form of the exponential form of any complex number. This part here should be positive. We don't have this I. We should not have this I. So we write it in exponential form. So we know that e to I pi over 2 is I. So this is e I pi over 2 times e I theta. Okay? And using the rules of exponents, we get e I theta plus pi over 2. So in this case, our z can be written as minus sine theta plus I cosine theta is e to I theta plus pi over 2. Okay, it's raining, so I'm trying to record these videos while it's raining, and I feel the rain. I like it. So here we found the expression, the exponential form for this one. We had to write I in exponential form because we need to have only the norm here, and the norm is 1 in front of the exponent. Okay, this is very important result to notice. Okay, thank you.